Hi, my friends. This is 1.2 lesson, solving multiple step equations. So this lesson is going to be pretty easy. I just want you to learn how to solve a multiple step equation by using inverse operation. Hopefully by now you understand what inverse operation is. It's just taking the opposite of what you have to get rid of it on that side. So to solve a multiple step equation, simplify each side. So there's an expression on each side. So if I have 2x plus 3, so that's one expression, and I have it set equal to 8x minus 10. Okay, so I could actually solve that. So there's an expression on each side. So I want to simplify those expressions on each side before I start. And those are already simplified, those expressions that I put up there. So then use inverse operation to isolate. So I'd move the 3 to the other side, or move the 2 to the other side, and then move the 10. So let's go ahead and do a couple examples. So go ahead and write these down. So you need to be taking notes right now. Make sure that you write down your learning goal, what you're supposed to learn, just so you can kind of check to make sure you learned it at the end. So our first example here is solving a two-step equation. So if you need to pause the video and go back and get that first page, please do that. Okay, so I need to look, my first thing is I need to look and see where the variable is. So I can see right now that my variable is t right there. So I want to get t by itself. I want to isolate t. So I always want to do any addition subtraction first to do my isolation. So I'm going to do subtraction property of equality, inverse operation. So I have a positive 2. So the opposite of a positive 2 is a negative 2. So now I'm going to just simplify that. So now I have 5t, so I'm going to bring everything down, is equal to 10. Now I'm going to go ahead and, so now what I see next to t is a multiplication problem. So I know the inverse operation of multiplication is division. So now I'm going to just divide both sides by 5. So that's going to give me t is equal to 2. So I just want to check to make sure I got it right so that I didn't make any mistakes. So I'm going to just take and I'm going to substitute it back into the original equation is what I'm going to do. So I'm going to say 5 times 2 plus 2 equals 12. And now this is 10 plus 2 is equal to 12. So this checks. And this is actually so important when we're using negative numbers, because so many times we drop a negative because we're rushing and then we get the answer wrong. But when you check it, you're going to get it right because you'll look for your mistake. Our next one here, I have 14 is equal to 9 minus p. So again, I know that I have a 1 in front of my p, that it's just not written. And so I need to do my addition subtraction first. So I can see that my 9 is positive. So the opposite of a positive number is a negative number. So, and I'm going to move it over the equal sign. So now this, go ahead and simplify this. 14 minus 9, all right, is 5. Bring my equal sign down. And what I have now is a negative 1p. So I need to get rid of that negative 1. So I'm going to divide by negative 1. And so now the answer here is p is equal to a negative 1. Or, I'm sorry, p is equal to a negative 5. So, but if for some reason you drop that negative, you're not going to get the correct answer. So we're going to substitute it back in just to make sure that we get the correct answer. So 14 is equal to 9 minus negative 5. And this is kind of like what our warm-ups were, this negative negative here. So 14 is equal to 9. Negative negative is plus 5. So 9 plus 5 is 14. So that checks. All right, let's look at the last example. It's a fraction. And remember, we know a fraction is just a division problem. So opposite of division is multiplication. So we're just going to get rid of that fraction. So looking at it, we know we need to isolate the variable. So we're always going to do addition, subtraction first. So I have a positive 7. So I'm going to do a negative 7. So I'm going to move that 7 to the other side. So I know I just subtracted both sides by 7 to do the inverse operation. So now I have h over 2 is equal to 3. So like I said, fraction is just a division problem. So opposite of division is multiplication. So I'm just going to multiply both sides here by 2. So this just simplifies down. So now I have h is equal to 6. So we're just going to check it just to make sure we got it right. So 6 over 2 plus 7 equals 10. And you can see I just always substitute it back into the original equation. So now I'm going to, 6 divided by 2 is 3. 3 plus 7, I'm just going to simplify that. It's equal to 10. And this is 10 is equal to 10. All right, so and that checks. Okay, so let's do another one. So that was example 1. All 3 of those were kind of the same. So we're going to do another one, example 2. So go ahead and write these down. So now we're going to combine like terms. We're going to simplify the expressions. Simplify the expression on the one side. So our first example here, number 3. What I'm looking at, so I always stop and I look at what I'm about to do, and I always ask myself, what do I know? What do I need to do? So I need to simplify the expression first, so I'm going to simplify this side here. And so I see that these two right here are like terms. These are like terms. They both have an x. They both have an x. And I'm just actually going to erase this, so because I don't want you to get confused if you checked out and then check back in and go, huh, what's she doing? So those two are like terms. They both have an x. So those are the two that I'm going to combine those two. So all I'm going to do is I'm going to add, or I'm going to subtract the coefficients. So the numbers in front of that variable. So I have 9 minus 6. So that is 3. And then I keep my variable. And then plus 15. So now I have simplified that expression on that side. So now I'm going to go ahead and I'm going to isolate x. First thing I do is addition, subtraction when I'm isolating x. So I look at my problem. I have a positive 15. Inverse operation is a negative 15. So go ahead and bring down my 3x. And so 15 and 12 is 27. But what did I forget? Right, it's a negative 27. So do not drop those negative signs. Okay, so now I just need to divide by 3 because that's all that's left. This is a multiplication problem. So inverse operation is division. So x is equal to a negative 9. So now I'm just going to check it in my original problem. So you don't want to put it into the simplified problem just because what if you made an error? So we're going to just pop it back into the original problem. So 9x, so is a negative 9, then minus 6, then x is a negative 9, and then plus 15. So now I'm just going to simplify that. Just need more space. So this is negative 12, This is a negative 81. This is a positive, negative, negative, multiplying it together. This is a multiplication problem because of the parentheses, is a 54, and then plus 15. So negative 12, and I'm going to go ahead and 54 take away from 81 is 27, and it's negative because the 81's bigger. So 27 minus 15 is 12, and it's a negative because the 27's bigger. So therefore, it checks. All right, so we checked it. Let's do the next one. Okay, so once again, I'm just going to look at the problem before I start and just kind of ask myself, what do I have? So I have my variable of x's. So I have this x here, and I have this x there. That 6 is positive, that 2 is negative, so I need to combine those terms. So that I need to simplify this side first. So I'm going to go ahead and do that. So 6 minus 2 is 4, and I have the x that goes with it. And then I'm just going to bring my 8 down, is equal to a negative 16. So now I'm going to go ahead and get the x by itself. But remember, I'm going to do addition, subtraction first. I look at my problem. I see that I have a negative 8 there. So opposite of a subtraction problem is an addition problem. So addition property of equality says that I add the 8. So inverse operations. So now I'm going to add the 8. So I have 4x is equal to, this was a negative 16. The signs are opposite, so I just subtract. So 16 minus 8 is 8, and the 16 is larger, so therefore it's a negative 8. So now I just need to, I have a multiplication problem that I can see. So now I'm just going to do a division. My inverse operation is division. So x then is equal to a negative 2. So once again, I want to check my answer to make sure I got it right. So I'm going to go ahead. I'm trying to move this out of the way. So I'm going to say 6 times a negative 2, 6 times a negative 2, minus 8 minus 2 times a negative 2 equals a negative 16. So I'm just going to go ahead and substitute it in, and now I'm going to simplify it. 6 times a negative 2 is a negative 12, negative 8, a negative 2 times a negative 2 is a positive 4, and that's equal to 16. So the signs 8 and 12, the signs are the same. 8 and 12 is 20, and they're both negative. So signs are the same. I'm going to add. So now I have 20 and 4. The signs are opposite, so I'm going to subtract. So 20 minus 4 is 16, and 16 is the bigger, 20 is the bigger number, so therefore it's a negative 16. So once again, it checks, it's correct. All right, we have another example here. So now this time we're using, it says use structure to solve a multi-step equation. That just means that we're going to use some of the properties. That's all that means. So looking at number 5 here, I can see that right away, just looking at the problem, I can see I have parentheses, but inside the parentheses, there's a variable. So therefore, since I have a variable inside the parentheses, I know that I have to use that distributive property that I love so much. So negative 2 times 4 is a negative 8g. And then a negative 2 times a negative 3 is a positive 6. So everything is already simplified. We simplified that expression. So now I need to isolate G. So I can see I have a positive 6. I'm going to do addition, subtraction first. So inverse operation of addition is subtraction. So negative 8G is equal to, so this is just a 30 minus 6 is 24. And it's positive. The signs are opposite, so I subtract. It's positive because the 30 is bigger. Now I have a multiplication problem here. So inverse operation of multiplication is division. So I'm just going to divide. So now I have G by itself. So 24 divided by 8 is 3. And I have one positive, one negative. So therefore, the answer is going to be a negative 3. So let's just check it now. Again, I said put it into the original equation is what I want you to do. So 4, so got a negative 3. And then minus 3 is equal to 30. So now I don't have a variable inside my parentheses, so now I'm just going to simplify that parenthesis because that's what order of operations says. So 4 times a negative 3 is a negative 12 minus 3 equals 30. So I'm not done simplifying that parenthesis yet. So 12 and 3 are both negative, so I'm going to add them together. The signs are the same, you add. So this is a negative 15 is equal to 30. So now I have 2 and 15. 2, a negative 2 times a negative 15. So a negative times a negative is a positive. And it checks. All right, so I have a treat for you just because I know you love word problems. Oh, you know what? I have one more of these. Oh, look at that. We got one more. Okay, so I have one more. Oh, there it is. Okay, so I need to look at this one and I need to say, okay, now I have my negative 5 over here by itself. So I got a bunch of stuff on this side. I have parentheses. So therefore, my first thing is I'm going to go ahead and use distributive property. So I'm going to just bring the 5h down. Plus 2 times 11 is 22. Then 2 times, and remember there is a 1 in front of this. So 2 times a negative 1 is a negative 2h. And that is equal to a negative 5. So now I use my distributive property, but now I have some more terms that are alike. I have my 5h and I have my negative 2h. So I'm going to combine those. That's my next step, is to combine like terms. So 5 minus 2 is 3. So when I just look at the coefficient, the number in front of the variable. So 3h plus 22 is equal to a negative 5. And so I have that side all isolated. So now I'm going to just use my inverse operation. Opposite of a addition problem is a subtraction problem. So a negative 22. So my signs are the same over here. My signs are the same. So therefore, I'm going to add them together. 5 and 2 is 7. And then 2. So a negative 27. And now I have 3h on this side, just because this goes down to 0. So this goes down to 0. So now I'm just going to divide by 3. Divide by 3. So h then is equal to a negative 9. So let's once again go ahead and substitute it back into the original equation is what we're going to do. So 5 times a negative 9. And you can see each time I'm putting parentheses around where the variable was. I mean, that is just a good strategy. So 11 minus, and now I have a negative 9 is equal to a negative 5. Okay, so I have a parenthesis. I want to simplify that, and I also have a multiplication problem right here. So I'm going to go ahead and simplify that as well. 5 times 9 is a negative 45 plus 2, and my parenthesis now is 11 plus 9. Negative, negative makes it a positive. Okay, so let's just write it down again. So let's simplify the parenthesis. 11 plus 9 is 20. And you can kind of see here, I'm just going step by step so I don't make an error. And again, that just really makes sure that you're going to get this right. So 40, I mean, I could do some in my head, but it just doesn't make sense to. I mean, I could just easily write it down, and I know that I would switch things around possibly. So negative 5 plus negative 45 plus 40 is a negative 5, is equal to a negative 5. So that checks. All right, on to the word problems now. Okay. So I want to just kind of talk about word problems because we all love them so much. In just understanding what they say. So you just need to kind of break them apart. So let's read through it first, and then we'll go through and break it apart. So that's always a good strategy. Read through it. The sum of 4 and 3 times a number is 19. So some things I want to just point out. So sum, hopefully you know, is addition. So I know I'm using addition here. The next thing, so the sum of 4 and 3 times. So this here is multiplication. Is a number. There's my variable. Some number n is equal to 19. Okay, so let's see if we can put it all together. So I know it's addition. And I have 2 numbers there, and it's equal to 19. So that's what I know. So now I just need to figure out what goes in those boxes. So the sum of 4 and, okay, there's that addition sign. That's where that addition sign goes, at and. So 4 and 3 times, so I said 3 times n. So there you go. There is our problem right there. So now we're just going to solve it. So 4 plus 3n is equal to 19. So again, I'm going to use subtraction first. So 3n is equal to 15. And then I'm going to just divide by 3. So n then is equal to 5. So 4 plus 3 times 5 equals 19. 4 plus 15 equals 19. That checks. So 19 is equal to 19. That checks. All right, that was so fun. Let's do another one. Okay, the difference of, remember, read the question first, read it all the way through. The difference of twice a number and 7 is 9. Ooh. So difference means subtraction. So this is subtraction. So this is subtraction. Subtraction. The difference of twice a number. So twice a number, so this is multiplication. So twice a number. So my number is my variable again. And 7. So the subtraction goes there. And is just like a placeholder. Is 9. So 2n minus 7 equals 9. So that's what I came up with. So let's just solve it and check it to see if I got it right. So I'm going to do addition subtraction first to isolate the variable. Opposite of a -7 is a +7. So 2n is equal to 16. And this is multiplication, so I'm going to use division. So n is equal to 8. So let's just put it back in here and see if I got it right. I know this video is longer than what I like, but we're almost done. Okay, so this is 16 minus 7 is equal to 9. So this is 9 is equal to 9. So it checks. All right, one more, and then we'll be done. Because we like fractions, and I want to make sure we got one of these. All right. Okay, so it says 10 less. So I know less. 10 less, this is subtraction. So less means subtraction. All right, 10 less the quotient of a number and 3. So I know this is a fraction, quotient or division. That's what I know, that's a fraction. This is my variable. And is where the fraction is. So the fraction of n and 3. So it's going to be, this is going to be my fraction right here. And so n and 3 is equal to 6. So 10 is less than a number and 3 is equal to 6. So let's just check it to make sure that I got it right. So 10 is equal to 6. So again, I'm gonna isolate the variable. So I'm gonna do my inverse operations. First, so 6 and 10 are opposites. One's positive, one's negative. So I'm gonna subtract. 10 minus 6 is 4. And so therefore it's a -4 since the 10 is bigger. So now I need to clear my fraction here. So I just need to multiply by the denominator because this is a division problem. So this is a division problem. So therefore I'm going to multiply. So n is equal to 12. Let's see, getting in a hurry. Okay, so n is equal to, so a -4 times a -3 is 12. So let's just substitute it back in just to make sure it works. So 10 minus 12 is equal to 6. Okay. I'm sorry. That's I was just making sure I got the negatives right. So this is 12 divided by 3 is 4. So this is 6 is equal to 6, and that is correct. All right. Thank you very much, and we'll be doing some assignments with this in class. So make sure that you have watched the videos and you've taken notes. Thank you very much, and I'll see you in class.